And we are going to, okay, so today let us, if you recall, as it last class, we discussed about ensemble learning. So just a quick review, okay? And we discussed the three major approaches: majority voting, and bagging. So bagging is bootstrap, aggregating. Okay, and bootstrap aggregating is you pick samples. So samples with replacement. And the other parts are similar as majority voting. Okay, so that's bagging. The third one we discuss is boosting. Boosting is retrain weak learners. Okay, so you're going to pick the wrong predicted samples and retrain them. Okay, so that's boosting, and we learn adder boosting. And for adder boosting, it's use all samples, but adds weights. So the weak learners, so for the wrong predicted ones, the weights are going to be increased more for the next training. Okay, so that's a general idea that we learned. And we already started looking at the examples. And for the majority voting in sklearn, they also have the respective approach available. It's called a voting classifier. Okay, we can also directly use it. And the way to use it is, generally speaking, is you need to construct a list of classifiers. So various classifiers. So in this case, we have logistic, decision tree, KNN. Okay. So you create a list, and then you just plug in this list of classifier to the voting classifier. Okay. And in this case, then we do cross-validation. And for the cross-validation, we use the ensemble learning classifier. We're using this voting classifier, okay? And you can also collect the accuracy. So this is about the mean, and it's about 92%, okay? So it's quite straightforward, you can see. And for this voting classifier, you can also get of the parameters. And with the get parameters, a lot of time you can find like the hyperparameter, like in this case, the C hyperparameter, is that the depth for decision tree, okay? And for KNN, the number of neighbors, is it? So those hyperparameters, then you can have some idea with this get parameters. And over here it also show, because it's different folds, is that? And next we will see with those get parameter information, then we can also combine the ensemble learning with the hyperparameter tuning. So hyperparameter tuning in sklearn, previously we learned a approach called grade search. So we can combine them, okay, and then to have the better results. So the majority voting classifier last class, we already saw that's the author home crafted one, okay. And also last class, we also see for the evaluation, you can also use the ROC, okay, the area under the curve, okay. So those parts we this is just for the boundary decision drawing, okay. It's pretty similar as what we already learned in all of our previous examples. Okay, so what next? Let's see. For the grade search, previously we learned as it's from the model selection, okay, and it can be used to tune parameter, hyperparameters. So we need to have a dictionary. So this is dictionary of the hyperparameter. So decision tree depth, is it 1 or 2? The regularization parameter C, is it? So you give a list of numbers. Then we can do grade search. Is it? For this grade search, if you take a look, the estimator, what we plugged in is that majority voting. Okay, and then for the grade search, we need to provide the grade parameters. Then over here, you can provide that list. Okay, and here it also support cross validation, so 10 folds. And here is the performance measuring score. So we use that ROC AUC, okay. And then you can fit the training model. And then we can collect the results, is it? Collect the score, basically, okay. And it give us the output, and we can see the result is also pretty good. But we can also pick the best. So with the grade search, then you can also find the best parameter and the best score. Is it? So here it gave us the best parameter and the best score. Okay, after you get the best hyperparameter, and what the next one we can do is for this for our grade search, is it? Then we can pick our best estimator. Is it the best one? So over here, if you pick the best one, then you can see the best one for the regularization. C parameter is this 0.001, and the maximum depth for decision tree is 1. So it can help us to pick the best one, and then you can reassign the best one, is it? So over here, once you have the best one, then you can reassign it to the majority voting, okay? And you set majority voting's parameter with the best one. Okay, so on one hand, we use the grade search to find the best one, is it? And then you can assign the best estimator, is it? And its parameter to the majority voting classifier. Okay, so that you can have the best result. Okay, so in this case, it also adds in the hyperparameter. So overall of this discussion is how do we improve the performance from different angles. Okay. Okay, and then we can also see the majority voting, is it? The majority voting, and so we have the logistic regression with the best picked hyperparameter, and decision tree with the best picked hyperparameter, and the KNN also with the best picked hyperparameter. So even with ensemble learning, we can still use grid search, okay, to help us to find the best hyperparameter. Okay, what the next one example is about the bootstrap aggregating. Okay, we already kind of understand the basic idea. Is it for bagging? It's different from majority. If you recall, majority for different classify, they all share the same training data. So that's for majority. So the simple one, majority voting one. Okay, and for bagging, then it's different. Is it for bagging? Each one has their own training set, and the training set they have replacement from the original training set, the placement. Okay, so that's a major difference. Okay, and just like and I remember we also discussed this with replacement. Okay. Okay, and regarding the bagging, let's see the example. See, this example is regarding the wine data set. Okay, so all of those are pretty straightforward, and because it involves string, so over here we use label encounter. Okay, and then we just do test and train data split. And to using bagging, classify is also from ensemble package, is it? And over here, we are also going to use decision tree, okay? So the first one is the decision tree classify. Okay, so that's pretty straightforward. And then for the second one, we use a bagging. For the bagging, you need to specify the base estimator, okay? So in this case, we said, okay, we are going to use the decision tree, okay? And then you also need to specify number of estimators, is it? So over here, it's just a number of base estimators. So regarding this, okay. And the maximum sample, so over here, you give some coefficient. So in this case, it will be this number times the number of the size of the samples from the training data set, okay? And the feature for this parameter, this is similar idea, okay? So in this case, because it's one, so that means the feature you're going to pick is the same as the original, okay? Are we going to use a bootstrap? So over here, we said we are going to draw data with replacement, okay? But for feature, the bootstrap feature, we are not going to draw from replacement. We only have allow unique one, okay? So that's about this bagging classify. And then what next we try to do is we fit the model, is it, and then we can predict as for the testing, the training data. And after that, then we can collect the accuracy score. And here we collect both the training and testing accuracy score. So this part is regarding single decision tree, okay? And what is the next one? Collect is for the bagging one, okay? So we do the training and then you can predict on the testing, is it? And we can also collect the accuracy score, okay? And we can see the result with bagging, because with the training, if you take a look, the accuracy, no difference, is it? But with the testing part, the bagging one improved. Improve for testing. Set, is it for bagging one? For bagging classifier. So it improves, is it so? So you try different models, for machine learning, it's always you try with different models and tune parameters, then see what's the best result, okay? And the next part is similar, it's just as what we already saw a number of times, okay? You draw the boundary, decision boundary, okay? And the last one about ensemble learning that we discussed is ADA boosting. Is it? So for the ADA boosting, how it works, so here gives a general idea. Is it? So for the first round, suppose your prediction result looks like this. So this is a classic. This is the split line. Is it? And clearly, these two are wrong predicted. And because it's wrong predicted for ADA boosting, so ADA means adaptive. So you're going to add weights, so increase weights for wrong predicted one, or wrongly predicted one. Okay, and if you compare these two diagrams, you can also say for correctly predicted ones, we decrease the weights. For correctly predicted ones. Okay, then we do the training again. Let's do the training again. So then you may still have correctly predicted, wrong predicted, is it? Then similar. You are going to do the weight, increase the weight for wrong predicted ones again. So with the number of iterations we're doing this, then you can get the optimal result. Okay, so that's a general idea about ADA boosting. So here it also gives us an example, is it? So here we have the sample. Okay, and here is their indices, is it? And here is the real target value. And initially we assign the weights all with 0.1, is it? And here is the predicted result. For the predict, definitely some wrong, is it? And so we have 3 wrong and all the others are correct. And then you're going to update the weights, is it? For wrongly predicted, we increase the weights from 0.1 to 0.167. For correctly predicted, then we decrease is it to 0.072, is it from 0.1. So it's through weight adjusting, okay, for ADA boosting. And sklearn also has ADA boosting from the ensemble package. So for ADA boosting, similar, you also need to specify the base estimator. In this case, we also do decision tree, okay? And then over here, the maximum number of estimators, okay, at which the boosting is going to be terminated, and the weights applied, okay? So it's also pretty straightforward, okay? And then after that, then you can just do fit and predict with training and testing. And then we can collect the accuracy score, etc. Okay, so same thing for the ADA boosting. And we can take a quick look of the result. Okay, if you take a look this time, the result is the ADA boosting also increased compared with the single algorithm. So ensemble learning does help, okay? So here is the comparison between we use a single one or we use the ensemble one, and for the decision boundary, okay? Okay, so this example we are done. And there's another example in this unit. It's regarding, for this example, it's letter recognition, okay? So from also some image, okay? And, but this is different from previously, if you recall the MNIST. So MNIST is very, the classical one for handwritten digit. Okay, so this is different. And in this case, we just try to identify the letter A, B, P, R, okay, not all 26 letters. So let's see, and we use different ensemble training, okay? So we have the CSV file, and for some of the, anyway, it's regarding some image and it's already numericalized for us, okay? And the data set is also quite large, it's 20,000, okay? And then, so this first column is about the 4 letters. Of the remaining, just some features, okay, regarding the image about the letter. And then we just do the, like what we did before, split the training and testing data. The first one, what we did is use logistic regression, okay? After logistic regression, we do the training and then we predict with testing data, is it? And then we try to collect the confusion matrix for predicted, for the testing data part, okay? And also collect their score, okay? Precision recall and F1 score, is it? And you can see the result is not true. It's also pretty good, it's 95%, okay? So that's the first one. The second one we are going to do here is we are going to do the bagging classify. Okay, do the bagging. And the base one in this case is decision tree. Okay, and the number of estimator for the decision tree is 100 in this case. And we also apply the cross validation. Okay, for the ensemble classifier, and the average accuracy is 97%. If we compare with the single one, it's mostly 95%. So it does improve, okay? And what is the next one try to show is about random forest. After we learn ensemble learning, basically we can see random forest is a kind of ensemble learning also, okay, because it's used multiple trees, okay. And with random forest, then in this case, we can see the accuracy can reach about 98%, okay. And what the next one is about the ADA boosting, okay. And with the ADA boosting, and in this case, we reduce the number of estimators. We just try, okay, want to take a try. And then with the cross validation, and we can see even with the ADA boosting, then in this case, the result is not good, okay, it's 85%. Okay, there is another one, and we can also do stochastic gradient boosting is also available, okay. And with stochastic gradient boosting, what it does is at first build the learner to predict the values, is it? But then it calculates the loss, okay, calculate. And then based on the difference of the first learner and the real value, is it? Then it will build a second learner to predict the loss after the first step. Okay, so you can also use gradient concept for boosting. Okay, so ADA boosting is because we are going to change the weights for the samples. Okay, and over here, because gradient descent is based on the loss, is it on the loss? The loss is the predicted value and the real value, is it, for the loss calculation. And then in this case, we do gradient boosting, okay. And what over here, the number of classify, we get it back to 100. Then the result, you can see it's pretty good. It's 98%, okay. What is the last, the next one show is about the majority voting, is it? So voting classifier, okay, we already saw that. And regarding this, then just like what we said, you need to build a list for multiple classifiers. So in this case, we have logistic and we have the decision tree, and we also have the SV support vector machine, okay. And with this majority voting, then the result can be about 97%, okay. Okay, so that's all about the examples for ensemble learning. So I think for ensemble learning, let's just stop